Okay, section 6.6. We're learning how to find determinants of a matrix and also how to use determinants to solve a system of equations by using what we call Cramer's rule. I'm assuming named after some person with the last name of Kramer who figured it out. Okay, so determinant is a real number assigned to a square matrix. So notice it has to be a square matrix, and it's a real number. It's kind of like an absolute value, although it doesn't have to be positive. It's like taking all of the numbers in the matrix and representing them with one number. It's a very interesting concept here, and there's probably more research out there about how it works and what it's for, other than what we're going to see it used for today. Okay, so the determinant of a 2 by 2 matrix is fairly simple to find, and in fact, we learned about it briefly when we were doing inverses, because it's the beginning part of the 2 by 2 inverse formula. So if I have a matrix ABCD, then the determinant is simply found by multiplying these two numbers together, and then multiplying those two numbers together and subtracting. Okay, so we're just going to start with that process for this here. So we're going to go 4 times 1. Of course, order matters, because if you do them in the wrong order, then your answer will be positive when it's supposed to be negative, or negative when it's supposed to be positive, or something like that. So all I'm doing is cross multiplying 4 times 1 and 2 times -3, and then I'm subtracting those two numbers. So 4 minus -6 is the same thing as 4 plus 6, which is a determinant value of 10. So that is one number that represents this matrix. All right, let's look at a 3 by 3. And we're going to learn two different ways to do a 3 by 3. This one is the one you typically see in most books. So here's what happens. You have to be able to do determinants of 2 by 2s to do a determinant of 3 by 3, and then the pattern continues for larger square matrices. So first you need to memorize this little pattern of positives and negatives, because that's important in the process, and I'll show you why in a minute. So given an n by n matrix A where n is greater than 1, so obviously we don't have negative numbers in matrices, so that's just a disclaimer. The determinant of A is the sum of all the entries in any row or column multiplied by each entry's respective cofactor. The cofactor is the determinant of the matrix that remains after we ignore the row and column for each entry in the chosen row or column, multiplied by 1 or -1 according to the following pattern. Alright, how much sense did that make? Well, it's about as clear as mud, I'm sure, because this stuff is a little bit complicated to understand, especially when I'm going through it so quickly. So, I'm going to choose any row or column. I can choose the top row, the middle row, the bottom row. I can choose the left column, the middle column, the right column. It doesn't matter at all what you choose. In fact, it might be advantageous to choose one of the ones that has 0 in it, because then you'll have a piece of it that cancels out. I'm not sure I want to show that particular thing to you for your first experience. So why don't we just use the first row? We're going to choose row 1. Okay, so here's what I do. In row 1, I've got a positive, a negative, and a positive. So when I do this process, I'm going to have to multiply that positive 1 by a negative 1 because of the negative right there in row 1. So I'm going to end up using a -1 for that value. So just remember that. Use -1, and that's because of that thing right there. Anyway, okay, so we start, since we're using the row 1, we start, so let me use a highlighter. Highlight row 1. We're going to start by choosing the first number, which is 3. So 3. Now, if we ignore this column, because 3 is in that column, and we ignore the row that we chose, then we have this little 2 by 2 matrix right here. So then we're going to do the determinant of that matrix. By the way, when you just do like straight lines instead of the bracket lines, I think I forgot this on the previous page, that means determinant. So when it's got brackets around it, it's just the matrix itself. But when it's just these straight lines, kind of like an absolute value, it means determinant. Okay, so then we would have a 1. However, we've got to use a -1 because of this pattern of pluses and minuses. So I'm going to do a -1 just to be able to see what's happening here. I'm moving this line to cross out the column that number is in. So now I'm going to use the other numbers that are left over as a 2 by 2 determinant. So 0, 5, 2, 4. Then the last number in my row is a 2, and that is a plus. So I'm going to put a plus here. Now just to be clear, if this number right here, the 1, the positive 1, had been a negative number, then that negative would have changed it to a positive, just to make sure we understand that. It would change whatever sign is there. Okay, so there's the column that 2 is in, and now we're going to go 0, -1, 2, 1 for the 2 by 2 that's remaining. All right, here we go. Let's find the determinant. So 3 times -4 minus 5 minus 1 times 0 minus 10 plus 2 times 0 minus -2. So that gives us 3 times -9 minus 1 times -10 plus 2 times +2 because we're subtracting -2. So that's -27. -1 times -10 is +10, and then +4. And the resulting determinant is -13. Like I said, a determinant can be negative, even though we use the little absolute value symbols, indicating that we're finding that value, that determinant of that matrix. So that's how we do it. Now, on this next page, it looks like last year, I actually did this same problem by using, looks like I used the last column instead. The reason I'm saying that is because notice how the last column is scratched out in each step. And then for the first one, row 1 is scratched out, then row 2 is scratched out, then row 3 is scratched out. So I did exactly the same process with column 3. And so I get different determinants along the way, and I have different numbers in here. Again, these are all positives, so that would be plus, minus, plus, minus, plus, minus, turning that -5 into, turning the 5 into a -5. And then add everything together, and I got -13 again. So same determinant, no matter which row or column you choose. Okay, let's look at 3 by 3s. I'm going to start a new